So you can shut down this room, you have the other room operating. Right? So it all depends how much money you want to spend, how much saving you get. The most advanced HVAC system that you can see around yourself is mostly in hospitals. You know? If somebody wants to do work in HVAC system business, I always tell them get an internship in hospital because they are so advanced in controlling the temperatures, right? And controlling the pollutant and controlling the humidity. It's a very well controlled environment. Sometimes, even during winter and summertime, depending on the operation you have, and this happens a lot in the hospital, you need to have cooling and heating at the same time working. Right? There are rooms that need to be heated, there are rooms that need to be cooled. And so you don't want to have an air conditioning and a boiler at the same time working together for two different purposes. A lot of times you try to use devices in between in order to exchange heat from one area to another area. And there could be heat wheels, there could be air-to-air heat exchanger, heat pipe can be used. There are many devices in order to transfer heat from hot area to a cold area. And some of them look like this. For example, I have air this way, passage of air this way, a passage of hot air that way. This is a cold air. They basically cross each other at some point, and they mix together, or they transfer heat on some surfaces like the heat exchanger. And what happens is this air becomes cooler, this air becomes hot, right? So you have a hot area, you have a cold area, you can somehow transfer the heat between them by using a heat exchanger. Perfect, try to do that instead of buying the boiler or increasing the capacity of your boiler. So you've got to look at all of the possibility of energy recovery system. I'll give you an example. A couple of years ago, I was involved in this factory, and they had 8 boilers. It was a factory for they were making water and those kind of dairy product. If you go to dairy product factories, they all they have is boilers because they have to boil everything to such certain temperature for sanitation, right? And what they do is with all of these boilers, and you have steams coming out of these boilers. So these steams can just go away, right? You can just lose these steams. Or you can get those steams, if they are high pressure enough, you can pass them through a turbine, generate your electricity, right? And generate the electricity at the facility you're seeing. Of course, there is a cost of turbine, there is a cost of the maintenance of the turbine and everything. But if you can do this kind of a system, you save a huge amount of energy because now you're not buying electricity anymore. You're self-sufficient on electricity, right? So you have to do this. When you do a factory auditing, you have to be a little bit more open-minded. You just don't think in the box that how much energy I can save. You always have to think what kind of other system I can employ in order to basically use the energy that is lost in this building. You know, this energy is being, when you're dealing with the dairy factory that they make butter and milk and those kind of things, they are going to use the energy to boil those material every day, no matter what. You cannot reduce the amount of the energy that they use in order of, for example, boiling the milk. Right? There's a certain amount of gallon of the milk is coming, there's a certain amount of energy is being consumed to boil it. But the point is, how can I use the rest of the energy somewhere else? When it comes to physical plants building, when you go to audit building, you see a lot of boilers. When it comes to boilers, it's very important to make sure that the burner is clean, the oil and the air, the gas that is coming and the air has a perfect ratio, right? Because there is a combustion ratio. For example, the recommended combustion ratio for this gas is 10 to 1. That means for every unit of gas, you need 10 units of air. Now, what happens if I put 8 units of air? I'm going to have incomplete combustion. So I'm not getting energy out of my gas that I'm paying for. That's number one. So let's make it conservative, and let's pass 12 units of air instead of 10. So I make sure I have enough oxygen for combustion. Now what happens is, air is coming from outside. When you combust it, it gets hot, right? So now you're basically heating up 2 extra units of air for no reason, just because you wanted to be conservative. So making decisions like that must be backed up by analytical calculation, you know, and you can easily calculate all of those things. The level of the CO2 in the flue gas, and all of those things. You're dealing with boilers. Every boiler has an efficiency, right? Usually you cannot change the efficiency of the boiler. Those are the things that is, by design, is there. But you can control the leakage out of the boiler. You can control the boiler controllers are clean and they are working properly. You can make sure some of the operation about the boiler. You can make sure the burner is clean. You can make sure the air-fuel ratio is correct, which is the most important parameter in the boiler operation. Those kind of things are in your control, basically. And when you do energy auditing, you got to do that. One of the things you have to do when you're dealing with the boiler is you always have to measure the content coming out of the flue gas. See how much CO2 you have, how much NOx you have, how much CO you have, because that gives you how clean or how good your combustion is. Because if your combustion is not good, you're wasting your money basically there. That's the first level that you have to go say. It's not that expensive to do actually. If you are a factory in Orange County, if you call gas company, they do it for free for you. You know, they come, they bring all of the unit, they put all of the sensors, they measure all of the, you know, chemical that is coming out of your stack, and they tell you how clean is your combustion process. Okay. So flue gas is a flue gas that is coming out of the boiler on the stack is a very good indication of how healthy your combustion process is by looking at basically percentage of different gases existing in that flue gas. And that should be done in an energy audit. If you do an energy audit, you must do that basically. A lot of times the combustion gas, the flue gas that is leaving the stack and is supposed to go to the air basically, right? You can use it for different purposes. It's a very hot air. Why do you want to let it go? You can basically, with that hot air, use that hot, of course that hot air is full of CO2 and NOx. You cannot use it as air conditioning, for example, air and put it inside the room, right? But you can use that in an air-to-air heat exchanger, heat up the air, clean air, and send it in the room. You can use that air, hot air, to preheat the water that is coming to the boiler itself, right? If I have a boiler, just like the water normally comes here, steams leaving the boiler, right? So difference between the energy level between water, which is cold, and steam, which is hot, is the amount of the energy that I have to burn here, right? It's different. So if I have warmer water, I'm going to have less energy to burn here. Very simple, right? So let's get this water, before it comes to the boiler, which is coming from the tap water, I take the tap water, I circulate it around here, which is hot, right? This is the flue gas. And then I bring it here. Right? So if this water was 20 degrees C before, now it is 45 degrees C. And if it's leaving, it's at 100 degrees C. So before I was heating it up from 20 to 100, now I'm heating it from 45 to 100. I'm going to have a saving of 20%. Downside, more pipes. These get rusty after a while. I have to make sure it's maintained, but it's nothing compared to what's saved I have. Right? So these are called heat recovery systems, or preheating basically. And it can be used a lot for many different reasons basically. You can even heat up your fuel. If this is a oil operating burner, not natural gas, oil, it's good to even heat up your fuel, your oil a little bit before it enters the burner basically. saves energy there too.